Welcome everybody. How are you all doing? Thank you everyone for joining us for the second week of the LightLink Hackathon. I hope you enjoyed the first week and also that you were able to attend some of our previous workshops. So if you were at the ones last time, we would have heard from API 3, where we heard from Vange speak about quantum random number generators on LightLink. And we were also treated to another workshop from Perion, where we heard from Amos about leveling up your gaming with XP. So really to kick off the start of week 2, we have Elliot here from Moon, who will definitely be able to explain a lot more than me about what they do. And we will also have a little bit of time for questions at the end. So I will be inviting him to the stage now so that we can hear from him. But in the meantime, just kind of so we had an idea about kind of how everyone was getting on from week 1, I just wanted to kind of remind people that you have the chance to book in a call with me. I can share a link quickly here in case you haven't already seen it, but you'll probably find it on any emails from me and also in the announcements page on the Discord. So please do feel free to book in a short call with me now or whenever kind of time that suits you best. And we'll be happy to kind of speak with you, discuss like whether you're still in the phase of finding a team, also whether kind of you're still ideating and wanted any help with that. So please do just keep in touch at any moment. So Elliot should be able to join the stage shortly, whenever he is ready.
Hi, I'm Elliot. I'm the CTO of UseMoon AI, and today I'll be walking you guys through just on a bunch of different things. So if we jump over to here, UseMoon AI. In this workshop, we'll be exploring the powers of AI-powered integrated wallets, and all of that. We will be. I'll be walking you through Langchain and the UseMoon API to build a custom chatbot to create wallets and send transactions. And also we will be deploying an AI-generated ERC20 contract on LightLink Pegasus as well. Moon is bringing AI superpowers, AI and Web2 superpowers to Web3. In the presentation, we'll be going through what is Moon, the workshop objectives, how does Moon work, and also showing off MoonUp, which is a really simple 2 lines of code onboarding platform that can plug into any existing DApp or even new DApps or projects as well. I'll be walking us through Langchain, and as I also mentioned earlier, we'll be also just integrating Moon into a Langchain chatbot and just interacting with the Pegasus testnet, creating new wallets and firing off transactions, and also deploying a smart contract and interacting with that. So Moon Up, it's the development experience is very similar to Intercom. You just have 2 lines of code, you inject it, and you just add it to any existing or new website, and you get social authentication, wallets, fiat onboarding, AI chatbot for the for the DApp as well, and just a bunch of really useful features. I'll also be showing it off very briefly later. So what is Moon? Moon provides social authentication features, including passkey, OAuth, and email and password sign in and log in. So users have a very familiar experience with just interacting with blockchain, because Web3 is very difficult for like the regular user, and Moon aims to just like help. Moon Wallet, it's a cloud-based hardware wallet service. We support every major chain, from Bitcoin, Litecoin, Doge, EVM to Solana, and Cosmos chains. Moon merchants, we're currently building a payment provider gateway, so users can, so merchants will be, or like Shopify or e-commerce websites, they'll be able to just like, users will be able to scan a QR code and deposit crypto, and the e-commerce provider will be able to just get USDC. Moon Data, we are building just a blockchain indexing service that AI agents will be able to connect to and query data. Moon AI is still in the works. We are currently building out, well, we have built out LLM compatible interfaces. So AI agents can simply just interact with all major contracts and all major blockchains. Moon SDK, development tooling. So in the main, we support all major languages: Golang, TypeScript, Kotlin, Dart. And it's the development tooling that we'll be using today to build out the AI integration. And MoonUp, it bundles it all up into a really just super easy to plug and play user experience. What is Moon? So Moon, at its core, it's cloud-based hardware wallets. Moon started out of the necessity because onboarding new users to the blockchain is really difficult, because the blockchain is complicated and scary, and getting users to install. Getting new users or people who have never experienced blockchain to install MetaMask and then have to go to an exchange and buy gas and then send it to MetaMask and then go to OpenSea. And most people don't have the like concept, or like, it's just an absolute process. And even the concept of gas is super difficult. So we've combined cloud-based hardware wallets with account abstraction and authentication and just a vectorized blockchain database to try to create the best user experience possible that both new users and current users and developers as well to just have the best possible experience. Why AI and blockchain? So AI very much provides the base. It democratizes all, like pretty much all technology, or like all processes. So Web3 is hard, and it's a lot easier for users to type out what they want and get the result that they want. So in the future, via Moon, with intents and other technologies, users will be able to just simply say, I have Ethereum and I want the best possible yield. And through intents and solvers and Moon infrastructure, it would automatically query just like what are the best, like the best performing yields historically, and then swap, stake, and deposit it into a vault for people to just get the best possible yields just by a very simple command. Autonomous agents as AI and blockchain allow just an automatic Moon allows for autonomous agents to just very easily interact with the blockchain, allowing for AI agents to pay each other or even humans. So a recent scenario of this, it involved just an autonomous AI agent going on a platform like Fiverr and hiring and managing real people to execute a process. And with Moon, it does allow just autonomous agents to just very easily plug and play on chain and allow real world value to be like transferred around. AI has a tendency to hallucinate and make stuff up. And currently all real LLMs or just AI in general, there is a delay between what the AI knows and what is actually happening. So combining blockchain as a source of truth for real-world data using oracles, it can help just cut down it can help cut down the amount of stuff made up, and also just provide up-to-date data on just real-world events or even pricing data and other things. So it can help just it provides a layer that AI can just have better data and also just more trusted data as well. Automation is really starting to kick off globally as well, and it's ever since COVID as well, we are seeing just more and more automation across the global economy, and the trustlessness and the openness of blockchains just enables for automation to be combined with real-world data. So in the future, we could even see a scenario of combining autonomous agents, seeing that combined with real-world data, we could see a scenario in the future where the autonomous manufacturing plant could need more of a specific part. It would then just execute the request on chain to another agent that provides a specific part. They could manufacture it, receive payments in escrow, and then on completion, the manufacturing agent would get paid, and this could all happen seamlessly and autonomously. So AI and blockchain are really just an absolute match made in heaven for just the future of global economies. So in this workshop, we will be building an AI integrated wallet application. We will be building an AI chatbot, which will be able to interact with Moon and execute transactions. We'll be also integrating text-to-speech as well using Whisper to allow you anyone just to easily just speak and get a list of accounts or get balances, and in the future combined with ENS or other domain name services, even just send funds to people. And we'll also be deploying a smart contract on LightLink using Moon. So Langchain, for this workshop, we'll be using Langchain. It is a framework designed to make developing language models, developing with language models as easy and seamless as possible. It wraps a bunch of the logic and provides a bunch of really useful tooling, including API specification parsing, and even interfaces for multiple providers as well. So you don't exclusively have to use ChatGPT. You could use Olama or even self-hosted models. Or if you also just want to plug into web browsing or Wolfram Alpha or just a bunch of different service providers, it's super easy and straightforward. So all of the example code, it's up at this GitHub URL. I'll also paste it in chat. Yep. So all of the workshop code is already up on GitHub for people to explore and play around with. All this is any environment variables are just set here, and there's two components: there's the React app and just a very simple Solidity compilation server that I'll be explaining in more detail coming along shortly. So I will swap to Visual Studio Code. Oh, there we go. That's a lot better. First things first, I will quickly show off MoonUp. So this is just a very I've compared the experience to just Intercom. You just simply need 2 lines of code, and it provides any DApp with just a whole range of really useful features, including fiat onboarding and offboarding and wallet management. So it just really, it should enable just new users and even familiar users just a lot more convenience in the Web3 space to just very easily onboard and offboard fiat, or just manage wallets, or a whole range of other features as well. It's still in beta and a work in progress. So as for the OAuth, the code and the other information, currently you can kind of ignore the OAuth values for just today. I will be including where to actually get the correct details for that section of the project, but those aren't mandatory unless you use the OAuth page. So we'll be just using sign-in with Ethereum today, just because it's a very familiar experience with just Web3 users. So as you just saw, I just signed in with Ethereum, and by doing that, I got a Moon API token. So the sign-in with Ethereum page, we hook up. So all of the entry logic for all Moon logic on React side, it's wrapped up into just the Moon SDK hooks. And this just provides all of the basic necessary functions for tonight. And you can also extend on this and and just really build out. So sign in with Ethereum, it's very straightforward. We Moon session key. Moon session key is a variable that is imported from the Moon Moon up/Moon types. So I will just head back into hooks again. That's for which local storage key, the Moon authentication data will be stored. And both the authentication types and the storage interface, they are completely like pluggable. You can just like plug anything into this as well, because it's a very simple and straightforward interface. Just to like really expand on, even just like XAPI keys for custodial wallets instead of user wallets as well. So with Sign In with Ethereum, we grab a challenge. We request all of the accounts. We grab Nonus challenge, and then we pass it, and then we generate this the Sign In with Ethereum message, and call personal sign, and then we post it to the authentication endpoint. And then that gives us the access token that we will be using for today. So now that we have the session token correct, we can head to the ChatGPT side. This is all very just like basic design wise, just like pure HTML, because it's not super important. So we have chunked all of the API endpoints into separate groupings, so that way you can use smaller context windows, because the main swagger.json file is actually quite big, and you do actually require like a fairly long context window, but the more context you have, the bigger the cost. So so it's super easy just to make it all pluggable. So So I've selected the accounts interface, which is the core EVM just logic. And then I've just typed in list accounts, which we'll call the list accounts function. It'll hit ChatGPT, it'll interact with Langchain, and it'll return just the list of accounts currently under this token. And to create a new account, you can just do create account as well. And it will send a post request, and it will create a new account as well. For the sake of this demo, we will be just using the first one as well. So in chat interface, we initialize the use Moon SDK hook, and we grab the Moon SDK interface. And then on render, we set up the Langchain instance, which we're just using Chat Open API, which is just a very simple wrapper for Open API calls. And with temperature 0, and we can also change the model name. 1160 is very useful for if you want to return force it to return JSON as well, and then we create an Open API chain, which we pass in the Chat Open API model and the authorization headers. This is where we pass in the selected API specification, which is just Open API docs. And yeah, we just pass in all of this information, and we create a new chain. And whenever we select a different Swagger API specification, it will automatically swap to the correct one and reinitialize it. So the core logic is very straightforward. This is actually all you need to just interact with Moon API via Langchain. Just a few lines of code and just some text boxes, and you can just fire off transactions as you like. So for this next part, this is a pre-made prompt that mostly works. Earlier I've created just earlier on LightLink Pegasus, I've created a new ERC20 contract. And I've minted 1,000 tokens just for this demo purpose. So we'll be sending one. This is in way, so it's actually like 0 to the like power of like -16 or something. 2, the second account that we have in the contract, that we have in the Moon interface, the Moon wallets. We are specifying chain ID. So if you want to use mainnet Ethereum, you can just specify that in one. But for the sake of this purpose, we will be using LightLink Pegasus. I've grabbed the contract address from Block Explorer, and that will set it to use that contract address. We want it to specifically use the B6 account, and we want it to call the transfer function for ERC20 token. So let me head back to... So last transaction on Pegasus from this account, it was an hour ago, and I called token transfer. So and for this, we will also be using the ERC20 interface. So I hit send. It posts to OpenAPI. This specific model, it does take a little while. And then it's returned, and it's called the transfer. It did fail, or it kind of failed. That's just an issue on my end, so we reload this. And it executed the token transfer transaction. So we've... on Pegasus LightLink. So that's really like all it takes to just like plug in AI to add AI integration using Moon. And as you can see, we also have a lot of flexibility just with how you can do things, and you can even execute Bitcoin transactions, or just like really anything, and even do exchange swaps, or interact with Yearn vaults, or just anything. But yeah, create Open API chain. It does like pretty much all of the heavy lifting for this integration, which is why I've also designed generated the Swagger specs in just a very friendly format. So you can just plug and play. And this is really the only just like extra piece of logic that you need to add on top of use Open API chain, just so Langchain can know exactly what is happening. So we will head back to the main page, and with Whisper. So you can do so. Whisper, it's a API offered by OpenAI. For the Whisper demo, we will just be using a use Whisper hook, just to make things like as straightforward as possible. You just specify the Open API key, and it gives you a bunch of just like variables and stuff. The initialized chain section it's identical to the previous page, because we just wanted to be able to execute transactions with Moon, and with the send. And once we hit the send button on the HTML page, we just pass in transcript.txt, which is the text, the generated text-to-speech element from that Whisper returns. List accounts. Let's see if... Yep, so you can do it in a much better interface, but currently it's just like 4 buttons. You have the start button for which plugs into the browser microphone and allows you to just talk and like have it just automatically turned into text, which we can then just send to OpenAPI and then just send to Moon. So this enables a whole new just like user interface experience and everything. And as you can recognize, this is all of the Ethereum EVM accounts under this account, and combined with ENS or other domain name services, you very well could easily just like build out, or you could with not just build out like I want to send like $10 to this account or even to a mate. You could just like build much more complicated blockchain operations, as long as it's just like wrapped up in Langchain, because you can build add in custom functions. So you could maybe do like a custom contract call or something, and then just plug it into Moon as well for the signing thing. So then you can just like talk and have and just like test out transactions, or just like build much more complicated or like new user experiences and just new ways for people to interact with the blockchain. And it's very straightforward as well. So this is the contract page. It's all of these pages are very simple, just like absolute bare minimum, because flashy UIs can just distract people. So the contract page, it's quite a bit different to the other 2 pages, other 3 pages that we've witnessed. We can there's a bunch of just use state, React, and data things, just to store data to display and to initialize Moon, or even or to store just information or interfaces that we need. There's a few functions this time. So on page load, we initialize just the chat OpenAI interface for this demo, because don't need it to call the Moon API by itself. We want a bit more control. So handle fetch. This will take in the name and the input that the user specifies. So the input would be like, I want an ERC20 token with that has an initial supply of 1,000. And these are just some very and using Langchain, it also makes templating prompts super straightforward. So we have the system message, and then we have two pre-conned like pre-made human messages. And we're basically just asking for Langchain to create a smart contract for a name that you can specify and an input, which is what the user wants to happen. We specified that we wanted to use the Open Zeppelin contracts, and it's just some extra extra necessary things for Solidity, just like Solidity version, licensing, and we also ask it to explain the functions of the code that it generates as well. It can be a bit funky at times, and then we have another human message that is basically just like, make sure to actually like follow the requirements, and chain.invoke calls Langchain with the prompts and the other necessary information for it to run. And then we get a result. And from the result, we will basically just extract the code block that it gives, which is the Solidity code, and then set it in React state. And then after we have the code, we need to compile the code. So this is just a very basic fetch call that just sends the name and the code, the generator code, to that API server that I mentioned, which is just a Solidity compiler, and it compiles it, it returns the contract API and the bytecode, and we set that information in React state. So for the compilation server, it's a very simple, just Express TypeScript server, very bare bones, just like what's like necessary for the demo to work. So we're using Solok as the Solidity compiler. So we take in name and content. We just double check that name actually has something. We specified the compiler parameters, and under my contract, we put the generated Solidity code, and just like very standard, just like Solidity compiler options, nothing too fancy. And then we want to load in all of the Open Zeppelin contracts. You could do it contextually, so actually like look at the contract and decide and figure out like what's needed. But just for the sake of simplicity, we just read the file system and load in all of the available Open Zeppelin contracts into memory. It's not very efficient, but it's fine for the demo purpose. And then we stratified the input, which is the Solidity compiler parameters here. And then we call compile, which executes Solok, compiles the Solidity code, and it returns JSON output. Just a bunch of console.logs, so you can actually see like what it has done and like just error checking. And then we extract the bytecode from parsename, which is the user specified contract name, EVM bytecode.object, and the API. And then we return it to the React front end. So and then once it's been returned to the React contract, we set it in state. And then there's the last component, which is deploying it to the blockchain, or in this case, LightLink Pegasus testnet. So Moon, we have a deploy contract API call / function. This allows you to just very easily specify the wallet that you want to use and then deploy the contract to. And it just needs the API, the bytecode, constructor arguments, which in this demo we won't be using, and then the chain ID, which that's set to LightLink Pegasus. So now we head back to this. So I'll hopefully it's big enough. So ERC20 token with an initial supply of 1,000, and let's name it workshop instead of OOO token this time. So we fetch the code. This is the handle fetch function, which is calling Langchain and OpenAPI to generate the smart contract code. This does take a little while, and you can also adjust these prompts and fine tune these prompts. These are just very much just bare bones minimum required to get the demo working. As we can see, it's generated the workshop contract with using OpenZeppelin ERC20 interface and ownable, and as we asked it will once it's been initialized, it will mint 1,000 workshop tokens. And then the next step is to compile it. So we hit compile. It will send a post request to that compilation server with just the necessary parameters, which is the name and the code to compile. And it may have failed. It did. So as a lot of the time, it does kind of not compile, but once we can actually get the proper prompt working, because AI can be all over the place, and just what it actually does with an initial supply of 1,000. Not use. Oh, I spelled that incorrectly. Yeah, in this process, just due to the nature of the compilation server, it's very, very basic. Things can and do go wrong, and combined with just semi-randomness of AI in general, it can just be a bit funky at times. But yeah, the access tokens, they have just a pretty short expiration time, so I'll just delete the session state. There's logic to automatically refresh the access tokens, but just to keep things very simple, I haven't implemented that in this demo, but that's yeah, that's fine. So we have oh. Oh yeah, as you can see, because the first request I didn't specify the token name, it's it just gives you my token, but the compilation survey doesn't know the context of it. This example is very funky. ERC20, which means an initial supply of 1,000. There are also faster LLM models that you can use, and Langchain, it does make it to be easy just to swap interfaces around and just like plug and play. So if you wanted to use like Google or self-hosted LLMs for data privacy reasons as well, it's super straightforward just to like swap it around. And Langchain is also really well documented with just like all of the examples and everything. Even in testing, this example took like 3 to 5 times to actually like generate and compile properly, and I haven't tested any other contracts either, so it is very finicky. So I just changed the token name to Moon Token instead of Workshop because it might be conflicting with some Open Zeppelin compiler or like yeah, it's just a bit funky. So hopefully this one works. If it doesn't, you can all. That looks good. Here we go. Okay, yeah, so that one decided to work. So as we can see in the request object, we send in the content, which is the generated code, and then just the name of the token, and we get back the API and the bytecode. And then we'll make sure that the account that we want is properly selected. And we will hit deploy, and that did not work. Let's try that again. I might have broken something. Okay, there we go. So I did break something. So I've hit the deploy button. We've sent Moon Vault the necessary information, which is API, bytecode, chain ID, and the constructor arguments, and it has returned success. So we will be grabbing the transaction hash from the API response, and we'll be heading over to LightLink Pegasus. And as we can see, it succeeded this time. And it created Moon token contract. It's minted 1,000 Moon, and everything's properly initialized. And we can even head over to here, and yeah, we can see that contract creation has happened successfully, and there should be a max supply of 1,000 Moon. And if we go back to the address, yep, 1 minute. Yep. So yeah, you can super easily just generate and deploy contracts. The demo is still a bit finicky, but with more fine tuning, you could get a really good user experience, or just even developer experience. Just with just being able to generate new contracts, and even AI agents could generate and deploy contracts based off of their like unique needs, or even there's a whole range of applications. So all of the and yeah, so yeah, using Moon, Moon enables a whole range of just like very unique and powerful features that just like help democratize the technology of blockchain and make it more accessible and universal to not only people but also autonomous actors that can just like seamlessly operate on chain, and just allow users to just like have entirely new user experiences that previously weren't possible, and with intense and really robust data as well, we will be able to eliminate a lot of just like errors, and just like make sure it's like very not controlled, but like within the constraints of what it should and shouldn't be doing. And questions time? Yeah.
We do have a few questions in the chat, Elliot, if you if you wanted to ask them. I'm sure if anyone does have more, please do put them in now, so we have a bit of time to answer them.
So with the OAuth variables, it operates very much as like login with Google or social authentication. So the user is sent to like the Google login screen, they select the account, and then you hit allow, and then the callback is where the Moon authentication will take the user back to, and it will provide a state and a code, and then from your end you will exchange the code for an access token for the user, and this allows you to just users who use Moon or just are familiar with OAuth or even developers as well, because using Moon you can actually build like hidden blockchain experiences. So like in like video games, for an example, you could very easily just like have a user like log in and they would never actually know that they're using blockchain for like NFT in-game items or other aspects to that. So not only I'm not sure about Roundup Wallace. Moon is an infrastructure project as well, so you can actually plug and play it with really anything at all. And we also do support and with like any existing wallet as well, you can just like log in with that wallet and get a new account, which some people are already using to essentially just like prevent their hot wallets from being accessed, because instead of like connecting your like main wallet or like wallet to the website, you can essentially use Moon as a proxy wallet type of thing and just have deposit and withdrawal functions as well. After sign up, you don't initially have any wallets. There's a bunch of create account or create account functions that you use to call, or you call to generate new wallets. And you can specify the private key into that. And then as for depositing tokens into that account, you can just make a new like transaction from the wallet that you're deposit, or like any existing wallet or even exchanges. With like Pegasus Faucet, I just copied and pasted the address, the output address, and then got issued testnet gas.
Okay, I think that is all the questions in the chat so far, and we are slowly running out of time.
Yeah.
If anyone doesn't have a question left, you can I can see someone is typing maybe frantically. But I will just provide a few more details before we wrap it up. So thank you very much, Elliot, for your presentation. That was wonderful, and I'm sure very helpful for everyone kind of taking on the challenge with Moon AI, and I'm very excited to see submissions. I think that is the same questions as before. I think so.
Moon is an infrastructure project, and we have tried to just like universally support just like as much of Web3 as we possibly can. So you should be. I'm not familiar with Roundup Wallet, but you should be able to, even if it's just like signing with Roundup or having. Like with the sign in with Ethereum demo, I just used MetaMask to just call personal sign and have MetaMask sign the necessary message for authentication. But you should be able to. I apologize. I'm just not familiar with Roundup Wallet, but. We do support like Rainbow Kit, and you can just like log in with really just any wallet, or even just like use it as a cloud-based hardware wallet as well.
Okay, perfect. I'm sure that answers their question. So yeah, this kind of concludes the third workshop. Thank you again, Elliot. We will be back tomorrow at the same time, 9:30 a.m. GMT, where we'll be hearing from Anthony from Lightflow, and that will be on creating a cutting-edge NFT marketplace with Lightflow. So anyone interested in NFTs should definitely join again tomorrow. If there's kind of anything on this workshop that you wanted to catch up on, this is being recorded and will be uploaded to the Hacker Pack. So you'll be able to rewatch this all again and kind of go over any bits that you might have missed or can't quite remember. But yeah, also before we end, just highlighting once again, you are filled to book in a call with me to reach out. I'd love to know how your projects are going after the first week. And if you need any help or advice, I'm sure we'll be able to kind of reach out to Elliot and kind of forward on any questions that may arise from building on Moon. So he can kind of help with any more technical aspects. But thank you all again, guys, for attending. I really appreciate you coming, and Elliot for giving up your time. Yeah, take care.
Thank you, Michael, for having me. It's definitely a pleasure to be here, and it was a bit janky at times, but if anyone has any questions, they can just reach out to me, and I will be, or I do monitor or keep a close eye on the Encode Discord. So if you run into anything or have any questions, and I will also be getting the OAuth example working as well. So
amazing. Thank you very much. See you later, everybody. Take care.